write the number 2.317 repeated, which is really 2.3171717 ... is a ratio of integers. In other words, what we are trying to prove here, I should have rephrased this and say, prove that 2.317 repeated, or 2.3171717 is a rational number. Okay? So, how are we going to start? We're going to write it as a constant plus a series, and turn out that this will be a geometric series. Watch. I'm going to write 2.317, where the 17 is repeated, as a constant component. It will be 2.3, right? Plus, it will be it will be 17. The first, let's see how we're going to write it. The first 17, look at this, the first pair of 17. It will be in the second and the third decimal place. So it will be 17 over 1,000, right? The next will be in the fourth and fifth place. So 7 will be in the fifth place. Again, 1, 2, 3, 4, 5. So it will be 17 over what number? 100,000. And the last one will be 6 and 7. So it will be 17 over 10 million. So at this time, I'm going to write it, okay, I'll write it as 10 million. Or better yet, I can write, and then we continue. So let's write it in a scientific, powers of 10 form. So it will be 2.3 plus 17 over 10, this is, 10 cubed, got it right, plus 17 over 10 to the 5th, plus 17 over 10 to the 7th, plus the next one will be 17 over 10 to the 9th, and so on. So, what the end result here is that you have, we have a constant plus the plus a geometric series. Okay. So we can write 2.317, where the 17 is repeated, as a constant 2.3 plus the geometric series and the geometric series, of course, will be what comes after that. So it will be 17, 10 cubed plus 17 over 10 to the 5th plus 17 over 10 to the 7th, and so on. Okay? So, in order to consider this as a geometric series, I need to consider that this is n equals 1, this will be n equals 2, this will be n equals 3, right? So the idea is, if it's a geometric series, we need to come up with A and R. So what A equals to and what R equals to? A is always the first term. Remember, because we have something raised to the power of something to the minus 1. So we have A here, and then we have the ratio R to the power of n minus 1. Okay, and this will be in the position, in the nth position. So what is A? The first thing, 17 over 10 cubed. What is the ratio between each two? What is the difference between, or the ratio, 17 over 10 to the 5th divided by 17, 10 to 1 over 10 squared? Very good. So we can write here 1 over 10 squared. First of all, we see that this is convergent, right? So r equals, it's less than 1, so this is convergent. This is a duh comment. You know what I mean by duh? This is a number, 2.3171717. It doesn't blow up, so we know it's a constant. We know that this has to be a convergent series. So that was like, oh, well, we knew that. All right, so how are we going to proceed from here? Well, if this is a geometric series that is convergent, and that's why I wrote it, then we know what's the sum. We know that S sub n will be A over 1 minus R, right? We have A, which is 17 over 10 cubed, and we have 1 minus R being 1 over 10 squared. And you can see some of the results or the characteristics of what I did or what I put on the board before I started this example. On the top we have, let's write it as 17 over 1000. Okay, this will be the numerator. The denominator will be 100 minus 1, or your 99, divided by 100, like so. Okay. So let's continue and simplify it a little bit. So it will be, let's multiply by the reciprocal. So 17 over 1000 times the reciprocal is 99 over 10. So it will be 10 over 99. Okay, so it will be 17 over 100. It has 100. And this is 100. Okay, and then we have 10 here, 99, so it's 17 over 990. Remember the example on the board, because the 17 start after this at the second decimal. All right, so the number itself going to look like this. So we have this one, the number itself, 2.317, where the 17 is repeated, will be 2.3. Now, what is 2.3? 2.3, I hate to mix decimal with fractions, but I'll get rid of the decimal in a second. 2.3 is 23 over 100. 23 over 10. Time for me to take a break. Plus 17 over 990. The common denominator is 90. It's 990, so we'll end up having 990 here, right? And you multiply 23 by 99 plus 17. Anybody with a quick calculator? What is 23? Actually, shouldn't have asked that because you can do it mentally, right? 23 times 100 is 2,300. 2,300 minus 23 is 2,277, right? Plus 17, 2,294, isn't it? So it's 2,294 divided by 990. There is a common factor, factor of 2, right? So we end up having 445 here, and divide by 2, you have what? 1147. Holy mackerel, this is the correct answer. Do it. Put it in the calculator. Do 1147 divide by 445 and get 2.317 repeated. Huh? Sorry, 495. Who said 445? I did.
I give it the 1147.
990 divided by 2 is 495. Now do it in the calculator. You should come up with 2.317 repeated. All right, guys. Couple of announcements before you leave.